Yeah, good evening all. Are you able to see my screen?
Yes, sir. Yes,
Okay.
Yes, Professor.
Yeah. Sorry, my camera is not working due to a Windows update an hour ago. So, not sure why this happened. But thankfully, my screen is able to share. So, the recording has started. So, let's proceed. So, today we'll move to the next aspect of inferential statistics where distributional assumptions are not there. So, distributional assumption means, as I have told you, for anything we assume that the data which we get in a column or whatever is normally distributed. So here that kind of thing won't happen here. Even though we use a form of distributional thing to check whether things are in the right path or not, but initial distributional assumptions of this thing will not be there. So it's not the mean or something of a distribution of a column of data. We see most of the median things here. And we do rankings and all, try to find out which group is better or something like that based on the data, whatever we have it. So that's the kind of concept we are trying to see now. So that is why these are known as non-parametric tests. Excel does not have particular to it, so it will be based on calculations. So today's files and all I have shared. So you open the table 11.1. So I have populated most of the things. So you have the data, we have some rank and all. I have the calculations for this and all. So we have to work on this and try to move further. Stop me in between if you have any questions. So let me try to best explain this. The first thing is not what we are studying is what is known as a Mann-Whitney U-test. So in other softwares like R or commercial softwares like SPSS, SAS and all, everything is readily available. If you have just a column of data, read the data, if you ask the, I don't say a function, a drop down box of doing this method. So it will do a Mann-Whitney U-test for you, not the kind of a thing for it. But for this kind of, good to know, like, I mean to say, most of the times we just forget about the calculation. At that point of this kind of calculation, we'll also come to know how exactly things work and all, especially for other things require computational powers, numerical calculations and all. Here it won't be necessary, at least for one or two of things which I'm trying to show you. So it is something like, let us consider the example. Suppose there are two competitive exams. A person writing one competitive exam may want to know how many people are getting marks above and below a median mark. So median means like center of the distribution. So that's what is important. And whether the median marks in the two competitive exams are the same. So we try to compare. I think newspapers do it. So after every board exams like CBSE board or ICSE or government, state governments, the board exams, etc., etc. They do all this fancy comparing of scores between what you call districts, taluks, and so these kind of things. So they don't do a Mann-Whitney test, but they do ranking and all fancy calculations. So that kind of calculations you are trying to have a data. We do what is known as the ranking of this thing. So let's try to do what is the thing which we have to do for this thing. So Mann-Whitney U-test is non-parametric in nature. It does not assume any distribution for the population. Mann-Whitney U-test is used for comparison of things. It is a non-parametric test analogous to t-test among parametric tests. We did hands-on exercise of studying the t-test, various forms of t-test. So it is analogous to a parametric test where distributional assumption was there. Here no distribution is there, even though we use the normal score or something like that from that and try to do it. So that's what we'll do. So So given below are the times it takes to complete a course. So I have a group one. So group two, I have something like that. So I have each one of the data which you see is a record. So if I say whatever is there in A2 is one record, it is for Amarnath, who takes 12 minutes or 12 seconds or whatever it is to complete. So in group one, there are about 10 people. In group two, there are 10 people. So that's so it might be here. So group one will be some person like say P1, P2 and all. So this will be P11, P12. So it's a comparison between two groups which I am trying to do it. So that's the kind of a problem which you are trying to solve. So I need to test if there is any difference in the times it takes to complete the course by two groups using man-Whitney. Assume the two distributions are similar. So there is no mention of normal or whatever it is, but distribution. Any data recording a column is a distribution. That you have to keep it in mind. So null hypothesis is two medians are not significantly different. Alternative hypothesis, two medians are significantly different. So this is what we try to do it. So slowly we'll do it. So please use the data set in the CSV file which I have shared you and the calculations in the notepad which I have. So everything is correct there. So if there are any challenges in anybody if anybody is facing any challenges. So it is entered here. Now I have to calculate the ranks using the rank function as shown in the figure. The formula for the first item is something like so. I have some rank and I have mentioned a 1 there. So the 1 in the formula indicates that it is in ascending order. If it is 0, it is descending. Ascending is 1. So I will copy this. So you also do with me and try to copy it and let's try to do it. So I'll be place it here, go there to the function bar, paste it. So what I'm wrong. So let me try to correct that. Placed at a different position, right? Kept it right. I don't know. Okay, I should place it at. Hmm. I think I have to change everything. I thought I've done it right. So tell me, like, what's the challenge? Place with something different. What happened? So everything is gone for a toss. Okay. So I copy to all the things which I have shown here and I press it. I get the ranks as similar to this thing. If you notice on my screen, the calculations which I did and the textbook also, it is the same. So all of you got it right? Can somebody answer?
Is it mandatory from start there, or we cannot start from the first?
Yeah, you can do anywhere.
Okay.
No, I thought, I don't know, like, well, say, I had put it in the exact cells what the author has put so that it was easy to copy paste. But I don't know, it is gone wrong, really wrong. I am not sure why this happened. It should not have happened according to me, but it has happened. No, I cannot correct things. Anyway, do it, but you should get the answers what you are seeing on the textbook and the calculations there. If you have got it right in your this thing, that's fine, no problem. So what about the others? How are you getting it? Can somebody answer? Okay, next I have to do the corrected ranks here. So corrected rank is the formula here. So for the formula here, I have given the exact nature of the formula here. So copy paste this thing. Oh. So
Nothing is working for me. Is it the formula meaning that, okay, the position B7, B, that is the number, then $B, the variable will come to the B, whatever the 7, it will come to B, $7. What is the meaning of that? Then colon, second row, 16, colon 1. What is that meaning? I could not understand the formula logic.
it is something like this, as you see on the textbook. I think you have the textbook by now, right? So it is.
Okay, I have textbook, but it's the I am a hometown and textbook is in Bangalore.
Oh, okay.
Okay.
So this is corrected rank is equal to rank ascending plus number of observations plus 1 minus rank ascending minus rank descending divided by 2. So this is the formula which has been done. So based on that formula, I am trying to calculate the corrected ranks on the rank done. So I should be able to get this for this one. There is a challenge. 7. Alright. When I say this thing, it is taking to something else. Okay, E7 it is taking. Okay, got it. Seven. Right, that's what I have. E7. Correct. Perfectly right. Okay, I'm getting around here. Is it because of brackets? I'm not sure. What's the reference from? Not sure. How can it be valid? It's perfectly right. Valid. So E7 is this one. E7. Yes. 7 minus rank of P7 comma something has troubling. Double brackets 7 plus the problem. To plus sign here. Solve this problem. Oh, yes. So there was a challenge in the formula. So you put a plus sign here where I am highlighted it. So you'll get the results. Now copy paste the other things. Answer. Control 1, 3, 5, 7, 8, 10. So get the rank as the data here. So you should be able to get this answer correctly. So this is what has been got here by the author. Last one is 1916. Yes, 1916, perfectly right. Now I should go to cell I-17 and paste the sum of ranks. I-17 is the sum of E20 to E29 here. So it should be below this. E20, 29, yes. So next is sum of E20 to E29. Copy paste it here. So number of observations for group 1 and group 2 is 10 here. I need to find the U1 and U2. So these are the formulas which has been translated to the what you call cells. So I'll try to find out U1 and U2 now. So copy paste it to give you the answer. Each. No, it's not behaving properly. I'm sure what's the problem with my Excel? So that should be at H17. Okay, now so this is the formula should work there. Challenge of reference. Don't know. Really happening. I-20. I-20 multiplied by I-21 it should. And now wait, taking I-70. I-20, I-21, I-17. The right answers. Have I translated this properly? N1, N2. N1 N2 is 10. N2 is 10. Yeah, I20, I21. I17 is some of that. R1 is what I wanted to tell. N1 multiplied by N2 plus N1. So can anybody correct me where I'm wrong? N1, I20, I21. Yeah, I20, I21. Is it a question of bracket or something like that? Okay, the bracket. Will it make a difference? Sure. I don't know. There's something wrong. Can somebody help me on this? N1 multiplied by N plus N1. That's perfect. Don't know. Okay. Please correct this. I don't want to spend much time here. I don't know. Some challenges. Probably I'll get the answers here. So it is 28.5 and 71.5. 0.5 plus 71.5. So it should work. This minimum of this comma. Yeah, that is 28.5. So Z is hopefully Z should come out correctly. Yes, it is coming as 1 point minus 1.62525, right? So my calculated P, which I have to do it here. Yeah. strong. Too few arguments for this thing. So should I remove this? Yeah, perfectly right. 1 minus ABS of Z 1, 2, 3 multiplied by 2. Perfectly, that's what I have done it. Here. 1 minus norm of this norm is. So correct that in your sheet. So probably that's the same challenge which we have for our U1, U2 calculation also. Yes, I'm getting 0.1041. If you are doing with me, you should get this number. Perfectly right. So how do we conclude this? Here the absolute value of Z is lesser than the tabulated value. We accept the null hypothesis. Also p value is greater than 0.05. So we don't reject the null hypothesis. Please remember this thing in our case. So these are very unusual things. Usually, that's what doing research projects and also you may end up in this situation where you may not reject the null hypothesis. So you may have to accept the null hypothesis. So here, the two medians are not significantly different. So what does that mean? So the values in group 1 and group 2 are not that much different is what we say in this exercise. So let me pause here for a moment. So any questions you have, I'd be happy to answer. Of course, with a caveat, so we did not get how to calculate U1 and U2. I think because of the bracket issue, I think so, but it's have been translated properly. Can do this thing probably as an exercise and let me know what's the kind of bracket I need to. We get this answer. So this is how a Mann-Whitney test is calculated. So we accept the null hypothesis. All the examples what we did in parametric testing was we rejected the null hypothesis and accepted the alternative. In that case, in this case, it is a reverse. Yes, please. Any questions? So that can be assumed that two samples come from the population the same way. Yes. So we may end up like this. We may go on trying to put something. But what data speaks is very important. That's what we. What data speaks, it has to be taken into consideration. Yes, any questions, any doubts? Yeah, anybody please?
No question, Professor. Yeah. Got it. Thank you.
Yeah. So this was the one of the non-parametric tests. So we move to the non-parametric test, critical values. I will not be doing this example. That's why I have provided you a link. We'll follow that link and do it. So here we consider the example. There are three competitive exams instead of 2 as considered. Then comparison of median marks of 3 competitive exams are done using critical values test. So this is a non-parametric test. It does not assume any distribution. This is used for the comparison of means when there was more than two groups. It is a non-parametric version of ANOVA. So we also did ANOVA, if you remember, in our parametric test. So it is a analogous to ANOVA in the non-parametric series. So for this problem, so we'll go to the, so I have provided you a link here. So we'll use this thing and try to do the same thing. The same example is there because the copy paste was a challenge. So I could not do much in that thing. So that's why I found out this on the web. So we'll be trying to using it. So let me close this data set. We'll use on the WhatsApp, I have shared you this thing. So what does the data speak about? Let us see. So researchers want to know if 3 different fertilizers lead to 3 different levels of plant growth. They randomly select 30 different plants and split them into 3 groups of 10, applying a different fertilizer to each group. At the end of 1 month, they measure the height of each plant. So what we do is, yes, step enter and all. So I have provided you the data already. So the total growth of a plant in inches, 3 fertilizers are used. So in cell A2, if I have to say, 7 inches is the growth of one plant. So if I have to say in B3, 17 inches is the growth of a particular plant. Like that, we have to understand cell by cell. So if I have the data like this, so we will use rank average function to assign a rank of each plant out of all 30 plants. So we'll try to do that thing. Let's see what is the rank which we get. So I'll use rank average A2, comma, $A2 up to C11, comma 1. So same formula, I go here, just try to modify according to the problem which I have. Let me close this, open one more. Okay, I'll paste it here. So this I have to change to average. So this will become A2. So this is $A, $2, E, $11. And one is ascending. So I'll copy paste this thing. So come here, I'll be in cell E1 or E2. I get 4. For your benefit, I will paste this in the chat window. Please copy it. All of us have the same thing. Copy this also. So I need to copy this too. So this is the data. I get it. So if you notice in the link which I have shared, you get the same kind of thing. The last one is 11.5. Yeah, that's the thing which I'm getting it perfectly right. More or less, it follows the same principle, but with a bit of change. So That was Man Whitney U. This is Crystal Vallis. So then calculate the sum of ranks for each column along with the sample size and the square sum of ranks divided by the sample size. That I have to do. Sum I have to, so that is R. This is my N. So this is R square divided by N. So what is the sum here? So use the auto sum function. So 153. So my 10 is, so I copy all the columns. So R square by N. So is equal to 153. Use the caret symbol 2 divided by this one, enter. So is it 2340.9? Is that answer? Yes, we are getting it right. Same thing, I'll copy it to. So hope all of you have got the same answers. So calculate the test statistics and the corresponding p-value. The test statistics is given by H is equal to 12 n into n plus 1 multiplied by summation of rj square by n minus 3 into n plus 1, where n is total sample size, rj square is sum of ranks, nj is sum of this thing. So we have to do that thing. So how to do that? N is 30. I have to translate problem. Okay. NKH p value. So the position that I took. So N KH p value. So N is 30. Because I'm translating the whole formula here. So there I am not translated here. Okay, they have calculated. Okay, the count of E2 to G11. Let me do that. Not put it blindly. Count of to G11. Yes, 30 I am getting. Next is count of A1, B1. Okay. Anything wrong? I'm getting 0. It should be count A, right? Or I made a mistake, so that should be count of A. For the text thing, for the count of A, I should get 3. So translating H challenge. What is the formula? Yes. Can somebody help me in that? What is the writing? 12 multiplied by, so no, divided by open bracket J2. Okay. J2 multiplied by J2 plus 1 we have got 1 closed, 2 closed, multiplied by sum of 14 G14 close the bracket minus 3 multiplied by J2. Yes. Have I put it right or is there any challenge? Okay, let's find out. So see, yes, perfect. 6.0. Yeah, perfect. For your benefit, I'll put it in the chat window. You can get it. So next I find the p value. So p value, get the p value 0.045. That's it. Yeah. If not it, can somebody tell me, or else we'll follow what he has taken. 0.045 is the answer for that. It is 0.045. So p value is 0.045. As an exercise, I leave it. So like this only you have to do it. So here I have used a norm distribution of this thing and got an answer. So is this the way we get it? I'm not sure. Try it out. Let me know. So I get a value of 0.045. I have to interpret it. So test statistics 6.204, p value 0.045. Since p value is less than 0.05, we can reject the null hypothesis that the median plant growth is same of all three fertilizers. We have sufficient evidence to conclude that the type of fertilizer used leads to statistically significant differences in plant growth. So H0 was no difference. H1 is certainly there is a difference. So here we accept the alternative here. Only man-Whitney was a challenge in our thing. So how to report the results if somebody has to take. He does it like this. A Kruskal-Wallis test was performed to determine if median plant growth was the same for three different plant fertilizers. A total of 30 plants were used in the analysis. Each fertilizer was applied to 10 different plants. The test revealed that the median plant growth was not the same among three fertilizers. That is, there was a statistically significant difference in median plant growth among two or more. So that's what is the conclusion we have to draw. How we have to put. So here also we say that there are changes or whatever it is, growth of the median. I mean to say the median, at least one of the fertilizers and all certainly different differentiates between the other two things. So that's the conclusion which we try to bring here. So that was on crystal values. Any questions you have, we're happy to answer you. Of course, didn't leave it as an exercise. Tell me in the next class, like, were you able to get this p-value? It is the same calculation like this. So what you have to do it, put it for this where I highlighted is the thing which you find out. Yes, question. Okay, so I see that there are no questions here. So let me move to the next. So we try to do the differential statistics, that is the correlation. It is an essential thing to do linear regression. It will be part of our next class. So it is very much important here. So we try to do this, understand this correlation. Let's see how it is done. Let me close this. So I have some yearly rainfall and a GDP growth. GDP means the gross domestic product. I think if you are a keen observer of economic trends and all the opposition parties shout and all GDP growth is, government says it is growing, somebody says the GDP growth is not there. So all this nonsense happens. Here somebody is trying to correlate the rainfall to GDP. So in every country they calculate GDP growth. GDP is a number which is a combination of your primary sector, that is agriculture, sector, that is industrial manufacturing, tertiary sector is service sector, where all the software and all people. So what is the contribution of them to the national economic growth is GDP. Here, no year, it is India or something, nothing is given here, just a data to correlate yearly rainfall to GDP growth is what we are trying to find out. Example. Some analogy to this. So consider the summer season, sale of air conditioners increases. So this implies a positive correlation between temperature and the sale of air conditioners. Similarly, there is a negative correlation between temperature and sale of room heaters. So that is what we should observe. So in summer months, I should see the sale of air conditioners. If I see a negative correlation by calculation, I should see a sale of room heaters should go down in a summer. Room heaters will go winter months. So I have two of this thing. So let me paste the data. I will try to note the correlation for this. So select this. Go to data. Go to data analysis. To have what is known as correlation. I say OK. So input range. Labels in the first row. Data are in the form of columns. Output range. So let me put it in E. Let's say OK. Yes, The answer. So yearly rainfall and GDP growth, there is a correlation of 0.97. So that is multiplied by 100. So it is 97%. Yes, when there is a very good rainfall, GDP grows. So it contributes a value chain. So agriculture happens properly. So agriculture is an input to manufacturing. To have manufacturing and all, that leads to all the other service sectors really contributing that thing. So it's a cycle, business cycle, or a cyclical nature of called economic growth. So that's why we say that there is a positive correlation of this thing. 97% the correlation between yearly rainfall and the GDP growth, especially about this data. So data here is about just about 7 records are there. Probably it is for 7 years. What is the GDP growth? I don't know which year and all. Probably it has been taken from some known sources only. So if you have this kind of a answer, what is the interpretation we can give? We see the value is 9.7. This gives the correlation between yearly rainfall and GDP growth. It is very close to 1 and has a positive sign, indicating a strong positive correlation to variables. That's the interpretation which we have to use it. So what is this thing? And so Excel or any other software will only give this thing. When you notice this thing, this is empty. Yes. So this is a mirror image. Usually it will give only this thing. This value, the mirror image is this. So if you see this way, yearly rainfall to GDP growth, it is this, that is near to 1. So I have got a very positive and a strong correlation between rainfall and GDP. So that is the kind of testing which we try to do. Of course, very good example of case study which you can also do. Sales of soft drinks in liters and sales of cotton cloths. People try to find it. You have very fancy also. People do it and have proved it. Does the sale of Bangladesh butter impact US economy? Somebody tried to find out this kind of correlation. Yes, people have taken this kind of fancy things and all proved. That's how people try to, especially economists, do this thing. So financial people or people in marketing, people try to do retail in some way. So all this kind of combinations, try to find out the correlation. So let me pause here for a moment. Any questions you have, I'll be happy to answer. Any questions, any doubts, difficulties?
No doubt, Professor. Thank you.
Okay. So we have no challenges. So anybody else? Anything? I think something should be running in your minds. Please, in case you have any doubts, difficulties. So just give a brief introduction to regression, and we'll stop. So we'll go to the next aspect. So we've already done this thing, if you remember. So line of best fit is what we try to do. I'll show how to do in an example and how to interpret what I'll try to do. And so for this thing, we already, so we had data, we inserted the data, and we put an equation to it. So all these things has been done. So that is through a graph which we did. So we never worked our way through this aspect. So using the theta, so this is the dialog box which we'll be using to solve the problem. So let us see what exactly we'll get an answer to this. We can see. So we have done it in our mathematics class, little bit of this. So we did an equation, how the equation comes. Do we have to fit an exponential curve and all? So based on the data we have, we'll do it. But this is a step towards your business analytics. So that's why the author, the professor who has written the book also uses the word predictive analytics. So today in business analytics, this comes under predictive analytics. For the EMBA classes where I teach, so I handle the predictive analytics through R software, the open source thing. Because many things can be done which Excel cannot do it. But how to do it in Excel is what which you will learn. So let's see what's the best things which we how to interpret and. So I think I have already showed you some slide deck of mine. What exactly you can expect out of that. Same thing we'll do. Of course, we'll solve the problem. So how to do, what to interpret is very much important. So this is what I had for today's class. Let me stop here. So once again, I ask if you have any questions, any doubts and all, I'll be very much happy to answer you.
Just one query that actually with you, sometimes we are not able to do 100% practice. In case after the class and we have any doubt, we can reach you.
Yeah, definitely. Yeah.
Okay, that WhatsApp number, because everything I could not practice because of the tight schedule some of his work. So I'll start. Actually, I'm sorry. Sometime if any issue, I'll mail you or ping.
Only thing is that you introduce yourself, like which class and all, so that is better.
Okay, that I'll do.
Yeah, that will do, not a problem. So if you want to talk to me and all, probably I'll give a time. You can introduce yourself. I can relate things. I can get back to you on. Okay.
Okay,
Email
Professor.
also is there. If you have any challenges, please let me know. Usually I answer everybody. So it may take some time, that's all, if you have some challenge. Because people as way back, at least if I can see, 22 to 23 years back, also people who are working with me also come back. Only thing is like I can't relate sometimes. But it takes some time, they introduce themselves and try to, usually I help them out. Not a problem.
Okay, Professor.
If you have any challenges, do reach out to me. So we have one more class. So that might be tomorrow or day after. That will be an 1 hour class on linear regression. So with that thing, come to an end. I think recordings and all Rajan would upload on YouTube. So you may get a intimation. Okay. Thanks for joining. Let me stop.
Thank you, Professor.
Thank you, sir.